Hello, this is ELB. Let's get back to work. So last time we got ourselves a working whip. Oh, I still have the game open. Look at this. Okay, here. Working whip. Let's do this. Totally missed. Can I hit it all? Who knows? Here. So what I'd like to do now is, I'm not really sure, honestly. Real quick, I'm gonna fix one thing. Slow aiming, false. Slow turning, false. So we're allowing them both. Might look a little funny though. Actually, if it looks so funny, then what if I did this? I think this works. Oh, hello. Okay. What if I just disallowed turning or aiming? What'll happen then? I'm not totally sure. It's been a while. Absolutely nothing. It really does look a bit odd. Anyhow. What are we doing next? Give me a moment to turn down my music just a slight bit so I can think better. We can definitely try working on the movement a little bit and seeing if I can't get it a bit better feeling, a bit better looking, something along those lines. So let's see. There is something I need to figure out first, and that is something having to do with math and vectors. So basically what I'm trying to do is I'm trying to say, if I am moving north at a speed of 10, and then I make a force of 10 southward, what'll happen? Assuming there's no friction, no gravity, no nothing, I should go to 0. As in, I'm not moving at all. But if I'm moving north and then I add a force of 10 to the north, I should be moving at 20. But then what happens if I'm moving to the north at 10 and then I have a force of 10 to the east? So I should be moving northeast, but am I going to be moving at 10 to the northeast? Am I going to be moving more east than north? This I'm really not too sure about, and I'm not totally sure how to do this. So let's look at these a little bit. So This section explains what a normalized vector is and how it can be used. Ordinarily, vectors can be used in many situations, but sometimes you want to constrain their values, like when dealing with angles, which is why we normalize them. This is essentially a mathematical trick that is used to convert a vector of length n to a vector of length 1. Okay? Meaning that the vector components get normalized to be between 0 and 1. These vectors are called unit vectors. To calculate a normalized vector, we must first have the original vector compounds, then have them get the length of the vector. We then divide each of the vector components by this length to get the normalized vector components, which form the normalized vector, in which the sum of the squares of all the coordinates is equal to 1. Okay, I'm already getting lost here. Let's figure out what the fuck a vector is, because I'm fairly certain I know, but I've never really worked with them before. So, at some point when creating a game of any complexity, you will probably have to deal with vectors. They are used in physics, in AI, in trigonometry, and many other situations. Ugh. I'm already yawning. But what is a vector? Well, to put it simply, a vector is a directed quantity. Okay? Let's start by looking at a one-dimensional vector, which is just the same as a single number by drawing a numbered line with an arrow starting at 0 and ending at 5. This is the vector A, which is equal to 5, and if we draw another arrow starting at 5 and ending at 8, we have vector B, which is equal to 3. You should realize that it doesn't matter where a vector starts. All that matters is how long it is and what direction it goes in. So vector B starts at 5, is 3 units long, and points to the right, making it identical to a vector starting at 0 and going to 3. Okay? Now, you can also see vectors together by putting the two vectors A and B end to end to get the vector C, which is equal to B. So what about negative numbers? Well, if in the above image a vector that points to the right corresponds to a positive number, you can see that a vector pointing to the left would correspond to a negative number, making a one-dimensional vector nothing more than a signed plus-minus number. This explains the essential concept of a vector, only length and direction, left to right in this case, count, not position. So what about two-dimensional vectors? Well, we can think of them as consisting not just of left and right, but up and down too. Now these are not actually vectors yet, as we still have to reduce them down to using their start and end coordinates. Okay. Looking at a vector, we can see it has a start coordinate of 2, 2 and an end coordinate of 4, 3. Or looking at vector A, we can see this. 2, 2, 4, 3. So, and an end coordinate of 4, 3, and so to get the vector from this, we need to reduce it down by subtracting the end coordinate from the start coordinates like this: x2 minus x1, y2 minus y1, and 4 minus 2, 3 minus 2 equals 2 to 1, equals 2, 1. So let's do the same for vector B now. (1.2) minus negative 3.2 and 2.1 minus 1.1 equals 2, 1. Notice something? These two vectors are the same. Cool. This is yet another demonstration that a vector has no position, only direction and length, and we can draw those vectors relative to each other around a local 0, 0 axes. This means that a vector is defined by two values, an x and a y position relative to the local 0, 0 axes. And what about 3D vectors? Well, they have this added dimension of depth to contend with, and should be calculated as positions x, y, and z around a local axes, something like this. Okay. So that's what vectors are. Okay. We can get point direction, point distance 3D. Okay, so what's a dot product? The dot product is a value expressing the angular relationship between two vectors and is founded by taking two vectors, multiplying them together, and then adding the results. Okay, the name dot product is derived from the center dot that is often used to designate this operation. The alternative name, scalar product, emphasizes the scalar, I don't know which, rather than vector nature of the result. The actual mathematical formula can be written like this. A times B equals, what is that, sigma with an N, and then AI, BI equals, oh my goodness, okay. So in 2D, the dot product of vectors x1, y1, and of vectors A, which is x1, y1, and B, which is x2 and 2, is x1 times x2 plus y1, y2, meaning the dot product in GameMaker Studio is calculated as A times B equals, oh my goodness, I'm getting confused. So the curious thing about the dot product is the relationship it has to the angle formed by the input vectors can be expressed as A times B equals length of A times length of B times cosine, or times cos of the angle. That is to say, the dot product of two vectors will be equal to the cosine of the angle between those vectors multiplied by the lengths of each of them. Here is an image to illustrate. What the heck? Oh my goodness. There are a few things that we can now state from any two vectors in relation to the result of their dot product. If A and B are perpendicular at 90 degrees to each other, the result of the dot product will be 0. What the heck? If the angle between A and B are less than 90 degrees, the dot product will be positive. So what does this mean for those of us that make games? Well, this mathematical relationship can be used in quite a few circumstances, but the best way to see it is to build an actual scenario and see for yourself what is going on. Okay, one of the simplest way to do this is to generate a simple line of sight, check for an enemy in, say, a platform game so that the enemy will see the player, and if they are within 90 degrees on either side of their vector normals. Basically, we have to get the vector normal from the enemy, and then we need to get the vector of the player to the enemy. We will then get the dot product of these vectors, and if the result is positive, the player has been seen. If it is negative, he hasn't. The actual code to get this working is supplied in the example below. Oh my goodness. So, it's simply to see whether or not it's at a certain angle. Yeah, I'm not totally sure about this. Give me just one moment. Okay, so hold on. Am I gonna have to teach myself a lot more? Okay, so with a quick Google search, I probably didn't already finish this out, but let's do a quick demonstration of how I think this is supposed to work. So let's say we're going in this direction, right? And we have, oh, no. And we have a force applied to us going, no? Oh my goodness, okay, so okay, you know what? I am getting super confused here. Okay, so how would I make this work? Still thinking about this. So we're going this way. No, come on. And then we have this force applied to us. So now our come on. I hate this new paint. So now our angle is that, right? If we're going like this, and then no, then we have this applied, and suddenly we're doing this, right? So the idea is to take these two and determine what the new length and angle is, right? Okay, so let's see if we can't start implementing this and see if it even works. I do quite like how that looks. Although I was told it looked more like a needle. Whatever that means. Anyhow. Sorry for my silence. Just noticed that my Xbox One controller has a bunch of gunk in it. I'm gonna grab a sewing needle sometime today and fix that. Anyhow, so hate to say this, let's prototype first. If I remove all you and start, are we gonna get any errors? No, we are not, but I don't know what just happened. Do I need to place a player? I mean, do I really need to? I guess so. Oh, yeah, because it didn't activate anything. Okay, well. Okay, well, let's just create a new room. Okay, so I'm gonna call this OBJ 2D physics test. Okay, so we're gonna call this gamepad. So we're only gonna be controlling the left stick here. What we're gonna be doing is we're gonna be doing axes count. Axes value. GP axes LH. Okay. Okay. So we'll call this stick H equals that, and then stick V equals that. Okay. Okay, now let's do this, and we'll call this physics. So here. We're gonna, let's see, we'll call this force equals 0, direction equals 0, or angle? Angle equals 0, there we go. Force equals 0, angle equals 0. Okay. Oh. So first thing we have to do is figure out this red here. So let's see. So the length is going to be force, and the direction is going to be angle. Y1 equals length dir y, force, angle. Oh. Okay. So we've now calculated. So, oh, here, real quick. Okay. That's 0, 0, right? Okay, so we've calculated this position, and now we need to calculate this position from this position. So y2 equals x1 plus length dir x. Oh wait, not y2. x2 equals length dir x. Here. Stick force, stick angle. Stick force equals point distance, distance 0, 0, stick H, stick V. Okay, that's our force. That's our stick force. Point angle, or point direction equals 0, 0. Stick H, stick V. Okay. So now we're doing stick force. Yep. Stick angle. Do the same for Y. Okay. And now force equals length, or equals point distance, yeah, force equals point distance from 0, 0, x2, y2, and angle. Okay, so to start, just a heads up, this isn't gonna slow down essentially. It's going to be really wonky looking, and I might even lose it, and it might just go straight off screen. Okay, here we go. Straight up doesn't work. Got it. I totally forgot to actually do that part. Okay. So let's see. So physics equals length is force, direction is angle, there we go. Okay. Still no. What the heck? Okay, force equals 0, angle equals 0. We are checking those. Oh, am I doing this? No, wait, no, that was correct. Horizontal, then vertical. How does that not work, though? Okay, come on. X equals x plus length directs, force and angle, which have been changed. Should totally work. Let's try this. Oh, no. Yeah, why not? Okay, so draw text, x plus 10, y plus 16, and then string force. No, we'll do force plus string angle. There. What the heck went wrong? Really? What the heck did I put down? There we go. Okay. Well, no. I can't get him to go in any other direction, apparently. What the heck? Okay. Oh, hello. That might be Y. Because it's not Y. It was X. Oh, that's super floaty. Okay. Let's do this. If stick H is above 0.3, or is below 0.3, stick H equals 0. If stick V is below 0.3, stick V equals 0. Okay, so that gives us a little bit of a dead zone. There we go, look at that. Whoa. What just happened? Oh, I know what just happened. Okay. It's below, or, no, and stick H is above negative 0.3. And stick V is above negative 0.3. So basically, if it's between those two. Okay. in order to complete this, I would say... Oh, here, let's do a quick screen wrap. That didn't quite work. Let's try this now. Nope. Okay. Never mind. Anyhow. Okay. And then force minus equals 1. Oh, no, okay, it really doesn't like that. Okay. Force minus equals 1. If force is less than 0, force equals 0. Okay. This is really odd. It doesn't quite, it really doesn't work how I want it to, obviously. Because it just feels weird. I have no idea what just happened. I was pressing down and it freaked the hell out. If I press down, I'm moving that way. What the heck? Oh. Of course. Don't want to do it by angle. gonna get the camera to follow the player real quick. So I think that was right. Yeah. No? Really? Why aren't you following that? I mean, what if I just did this? Oh, wait a moment. I know what's going on. Views, enable use of views, visible when room starts, yada yada. Okay. Oh, this is hurting my eyes. Definitely stop twice as fast. Oh, jeez. Okay, so, rather than having force go down by 1, let's try this, dividing it by 2. I think that no matter what, we're gonna hit a threshold where it can't actually slow it down anymore. Yeah. I'm still confused why the angles are doing more. Okay, if stick force is above 1, then stick force equals 1, and then stick force times 4. As to why it's struggling so hard with it, though. I mean, so the thing that I'm really trying to figure out here is what... How to explain this? Like, in reality, the more force we put behind it, the more we move. And it is our friction with the floor, I guess you could say, that slows us down. Hold on. Okay, I got about an hour before I gotta be at work. 4 to 9 tonight. So, let's see here. I think as long as it's below, or as long as it's above 1, it will keep the player from moving too fast. Yeah. Eventually there's just a friction that we can't deal with. So if we do this, we can get up to a decent speed. But we struggle to reach the top speed sometimes. Oh my goodness. Do I really want to do this? It's starting to feel like it's more hassle than it's worth. I'm not going to worry about it anymore. I can probably easily find a workaround for the ice thing. Do I know what it'll be yet? Not really. Is that okay? It is. So the question becomes, what should I work on now? And the answer to that is simple. Actually, here. Hold on. Gotta add the other players real quick. I'll put you way over there, because why not? Nope, wrong one. Okay. Nope, shit. There we go. .29 by 29, so it's about 29 pixels. in reality, it's going to be 28 pixels of space to work with. Okay, nope. Okay. Nope. $24, we'll do that. Okay. So I'm planning on adding another gauge right now. 2 probably. So I'm going to do +2, +8. Actually, I'm going to do this. Okay. Okay, HP bar. That's right. We're doing a stamina bar. Okay. Real quick, I need the colors. Okay. So var sgx +2, var sgy plus what would that be, 10 maybe? Var sgx +2 plus 363, var sgy +2 plus, no, plus 10 plus var sm gauge h c for now. Let's just do sea green and then sea lime. False. Okay. One, two, three, four. Times stamina divided by stamina max. Okay, so actually, rather than doing stamina, I'm going to do SP. Stamina points. Okay, so we're going to say SP equals 100, SP max equals 100. Okay. The stamina points of the player, the max stamina points of the player. Okay, let's see how this looks. Bigger than I thought it would be. Okay. Let's also do this. MP. MP max. The max MP points of max mana points of the player. The max, or no, the max mana points of the player. Okay, there we go. Mana. I guess we do sea blue and sea navy. Okay, then sea lime and sea blue. Okay. Not quite correct. There we go. Look at that. So I would like to pull those up a bit more. Let's say they're going to be 4. So this should be 6. Nope. And then, no, we'll do 7. Meaning this should be 12, I think. Okay. Let's see how this looks. Almost. There we go, 1 pixel apart. The fact that we still do those special attacks is kind of funny. So, stamina is supposed to work very similarly to how it works in something like Dark Souls. A dash will take some stamina, or a dodge will take some stamina, running will take some stamina. I'm intending on swimming to take stamina. Swimming to fast to take even more stamina. Actually, I'm going to test something real quick. Running as quick as we can. Anyhow. Just a moment. So, let's see how we can make this work. Okay, minus equals 1. Okay. And SP is larger than 1. Really? That's gonna be 1? What the heck? Okay, so what the heck? Okay, hold on. I'm gonna drawing self. X plus 16. Or no, X, Y minus 16. String SP. That's all I want to see. Okay, we're at 100. Oh, I see. I said I did wrong. There we go. I was expecting it to get down to just 1 pixel left. Although, what if I did it like this? Oh wait, wrong one. What if I did it like 1 plus 364? Let's see how this looks. Because I think that'll make it so that the bar actually fully vanishes. Looks correct. It's going down just fine. And bang, it's invisible. Cool. That's what we want. I'm gonna fix that for the others. Okay. Now we go back to step, execute piece of code, HP, SP, MP. First off, HP. If HP is less than 0, then HP equals 0. Okay? If SP is less than 0, then SP equals 0. Alright. So let's see here. Oh, and then of course MP. If MP is less than 0, then MP equals 0. Okay. So that's all fine and dandy, but stamina recovers, doesn't it? So how will we fix this? So what I'm figuring is this. Each time we will set SP last equals SP. Okay? So If SP last is less than SP, or no, if SP last is greater than SP, there we go. Whoa, just SP, come on. No! Jesus Christ. That is annoying as all hell. Okay. Okay. We can set okay. There we go. SP recovery timer is equal to 0. If SP recovery timer is larger than, I don't know, 10, so a third of a second, then SP plus equals 1. Oh, you know what? If HP is larger than HP max, then HP equals HP max. There we go. I think this works. We might get an error from not knowing SP last. In fact, I'm sure that'll happen immediately. Yep. Okay. Say last step, and then SP timer, I think it was. Just, okay, SP recovery timer. There we go. Okay. How many steps it takes to start recovering SP. The timer showing us when the player will recover SP. Okay. Okay. Straight up doesn't work. Good to know. What did I do wrong? If SP last is larger than SP. So, I mean, if it's larger than what SP was, then it makes sense that the recovery timer would get messy, right? If SP last is above SP, then the recovery timer goes to 0. Oh. That's what I was missing, actually increasing the timer. Running around. There we go. So something that I could do is I could cause the run timer to be something greater, maybe. Not sure. Here's. I mean, I'd also like to make it so that the lower, or the less slow the SP went, the better the recovery time is. Think of it sort of like in Ocarina of Time, if you use all the carrots, then you get then it takes longer for opponent to recover. So let's do something like this. And SP recovery timer is not less than is not less than 0. No. It's larger than or equal to 0. There we go. If SP is less than 0. Then SP, if SP is less than 1, then SP equals 0. Oh, nope. God, that's irritating. And SP recovery timer is equal to -30. There we go. No, that's not right, because then it'll just keep on resetting to negative 30. Um... So we're just trying to set it. If it gets too low, I don't think this will work. No, really? Huh. Let's try this. I'm pretty sure we're now going to get stuck at low stamina. No? Really? What the heck am I doing wrong then? Oh. SP recovery timer. Okay. I need to get moving soon. Yep, we are stuck at no stamina. Okay. Anyhow, I'm gonna get going, because I gotta get ready for work. So, thank you very much for watching. I hope you have a wonderful day.